This video will show solutions to the 2017 VCE Mathematical Methods Written Examination 2. Section A, questions 11 to 15. Question 11. We need to find values of a and b given a function f of x and information about local maximums and local minimums. In other words, information about the derivative function f dash x, which in this case is equal to 3x squared plus 2ax plus b. At the local minimum, where x equals minus 1, this derivative will be equal to 0. Substituting in minus 1, 3 minus 2a plus b equals to 0. Similarly, at x equals 3, the derivative will be equal to 0. Substituting in x equals 3, 3 by x squared is 27, 3 by 9, plus 2a by 3, so that's plus 6a plus b equals 0. If we subtract the first equation from the second equation, we obtain 24 plus 8a equals 0, which implies that a equals minus 3. Back substituting that into the first equation, 3 plus 6 plus b equals 0. That tells us that b equals minus 9. So a equals minus 3, b equals minus 9, and that will be answer D. A similar solution can be implemented on our class pad. We will solve a system of two equations with two unknowns. The first equation is when the derivative, so that will be d by dx of x cubed plus ax squared plus bx is equal to 0, given that x is equal to minus 1 at the first stationary point, and similarly x is equal to 3 at the second stationary point, and we'll solve this equation for a and b, with the class pad returning the same solution that was found earlier. Question 12. We are interested in the sum of the solutions of sine 2x is equal to root 3 over 2 over some interval. We can solve this equation on our class pad. We're going to have to choose some sort of interval for the solutions. We're given that the interval starts at minus pi. The upper bound for the interval is not immediately obvious. Sine 2x will have 4 solutions for every increment of 2 pi. Hence, if we go from, say, minus pi to 2 pi, we should get approximately 6 solutions, which may indeed give us the number that we need to sum. So that's a good place to start. Now we need to compute the sum of these solutions. That sum is minus 7 pi on 6, and we're looking for a sum equal to minus pi. So if we add another one, we get the sum we require. So the sum of the solutions is equal to minus pi when we include x values up to and including pi on 3, but not including the next solution, 7 pi on 6. So our domain has to have a greatest value of d of less than 7 pi on 6, but greater than pi on 3. And the only possibility from the 5 options provided is option C. Question 13. We are given 5 statements about the function h and asked which one is not true. Given that h is binomial in nature, having 2 terms on the denominator of the fraction, it is unlikely that e, hx all squared is equal to h of x squared, is going to be true. Looking a little more closely, h of x squared is equal to 1 over x take 1 squared, whilst h of x squared is equal to 1 on x squared take 1, and we can see that those two are not equivalent. So the answer is E. Another way to gain this insight is to use the judge command on the class pad. First of all, we need to enter our function. And define it as h of x. Once we have defined h of x, we can call up the judge command, which is found in the catalogue menu. And we can judge each expression in turn if required. So the first statement about h of x is true, and we could eliminate options until we found a false one using this method. Question 14. This question requires the variance of x. For that, we will need the mean of x, being the sum of x by p will be p by minus 1, so minus p, plus 0 by 2p, so that's 0, plus 1 by 1 take 3p. Giving us a mean of minus 4p plus 1. And we can use this to compute the variance. The variance is x minus mu squared times p, again summed. So the first part of our variance will be minus 1 minus mu squared and that's multiplied by p. In our first case, the probability is p. So the first term of our variance looks like that. With a slight modification, the second term of our variance can be computed. We'll change the x value from minus 1 to 0 and change the p value from p to 2p, giving us our second term of the variance. And the third term can once again be computed by modifying this expression. Summing these three terms will give us our variance. A simplification of this answer looks like this. Looking at our options for the variance, none of these appear to match our answer, although option D is looking suspicious. If we expand our expression, we can indeed see that the answer is D. If you happen to have a spreadsheet on your class pad that calculates the mean and variance for discrete probability distributions, it would be extremely useful in a question such as this. In this spreadsheet that I built and used throughout the year, I need to enter the values of x and the probability of x. The probabilities need to be entered as numerical values, or if they're algebraic, need to be entered with an equals sign. My spreadsheet computes the mean and variance. We can see the mean, the value that we saw previously, 4p plus 1, and the variance displayed in full as minus 16p squared plus 6p, the answer we arrived at earlier. Question 15. We are asked to find the maximum value of this rectangle. Given that its vertices include 0, 0 and u, v, it is u wide and v high, where v can be expressed as minus u cubed plus 8. Hence, an expression for the area of this rectangle is u multiplied by minus u cubed plus 8. This area expression can be maximized using the fmax command. We need to choose the start and end points with some care, between 0 and, based on our graph, 2. Maximum value is 6 by the cube root of 2, which is answer B.